we have to fix another dates and all. Even yesterday I had to cancel. There was only one person, but today I'm not going to cancel. Uh, Hope you can hear me.
Yes, one will join now. She's having a small problem.
Okay, okay, right. Right. Can you see my screen?
Yes, sir.
Okay. Last 2 days, we discussed about the database and their features, advantages, disadvantages, and how we can create databases. And showed you that by using a simple database like Access, how you can create very simple database program, right? So all those things we discussed. So today we are going to discuss a new topic, right? So about the networks. So again, this is not library networks. This is computer networks, right? So that is why I told always these are very technical subjects, technical terms are there, right? So even there's another class, same thing I had to repeat yesterday, Sinhala class. So it is very difficult to learn this type of lessons, especially something like computer in Sinhala, because some terms are very different than the and very difficult to learn than the English, I believe. But anyhow, I had to do. I'm doing that. Even though I explain those students, it's very difficult to remember those single words related some computer words. Right. This is about the networking, computer networks. So with this session, so we can have today and next week. I'm not sure whether we are having the next week, right? So today next week is following day after the Vesak. I believe there's no class. I'm not sure. Need to check with the Nilis, right? So ask from the coordinator. Uh, So most probably Saturday class will be not there. Then there will be no class on Sunday as well. I'm not sure. We have to check, right? Then these things will be discussed in our sessions. Features of networks, network architecture, network components, type of networks, network topology, network transmission modes. These are the things we are hoping to discuss within this session. First, let's see some features of networking, right? Some features. What is a computer network? Can anyone answer for that? What do you mean by a computer network? Can anybody answer? Someone? Okay. What kind of devices? Okay. So, okay. Okay. It explains something. Not 100% correct, but yeah. So there is, you have something, some idea about, yes. Others? Any idea? What do you mean by a computer network? Okay. A computer network is a collection of computers, communication hardware, and software that facilitate the sharing of resources and communication. The It includes the answer you said. So you said a connection. These things are computer network is a collection of computers. This can be a collection of computers interconnected or some communication hardwares. What are the communication hardwares? Someone can answer. What are the communication? Like, okay, You may have a router, switch, hub, those kind of communication hardwares, or some softwares. Maybe some other hardware like printers, scanners, those things. Those things are interconnected to share resources, right? To share resources and communication. Now take office environment, right? So take office environment. So in your office, maybe there may be 10 person working, right? 10 people are working together, right? So each of those people will having they have their own desktop computer to work at the office, right? So now they need to do some printing, right? They need to do some printing. Can you see 10 printers on each person's table? Are we going to buy in that way? 10 printers for each person? Normally, we are not doing that. It is a waste of money, right? Normally, in a computer environment, there will be one printer for all. That printer will be shared, right? That printer will be shared. Everyone can print through that printer because that, suppose this is the printer, that printer will share for everybody, all these people, right? Everybody can get a printout using this printer because this is shared among the network. All these computers are interconnected. That is a network. That is a network. Hope it is clear. So let's see very briefly some advantages of networking, right? Some advantages. Sharing data and information between computers. Sharing is one most popular advantage. Sharing resources. Sharing resources as well as information. Right? The main advantage of networking is the ability to share data and information between computers very easily and quickly. When you interconnected each of your computers, each of your digital devices, you can share information very quickly. That is why you can send an email to another person within few seconds. That is why you can send your even this your WhatsApp and all, that is some other networking part, telecommunication networking. Even that is how you can send very quickly required data and information sharing. When you consider the libraries, right? So this is very important factor. Suppose some of your users, patrons, is asking some articles, right? From a journal or some few pages from a book or something. Earlier, what you have done, how did you send these things to the your patrons, right? So what you did was normally in our libraries, what we did was 10-15 years back, right? So we just photocopied them and send those things through the post. That is how we send, those people came to the library to collect them. Photocopies, as the photocopies, right? So think about the time we are going to take photocopies to the to send through the postal service. It almost takes maybe few 2-3 days. But now how we are doing? Same requirement, asking some articles, same kind of patrons, but the way we are delivering, the way we are sending those information has completely changed. Now, how if somebody asks from your library, how you are send those required articles? Can someone answer? How do you say?
Via email.
You are sending an email, right? So you either you take some photos, because now there are digital devices, maybe from through your phone or any other scanning, or you can scan the materials, right? You can scan the material. So either you take some photos or you scan the material, and you either email, or basically you can send through the WhatsApp messages or something like that, right? So within few minutes we can do this. Earlier it takes days. Now it takes only few minutes. Sometimes you don't need to scan either, because sometimes those things are available as online form, online articles, e-articles. It is available in online, right, in our collection, in our digital library, maybe. So what you do have to do is just download it, or just send the e-copy to the your user. Within few seconds you can say. So now the way of delivering the service has completely changed with this technology development, right? Likewise, by storing the data or information in a server computer, the clients who are connected to the network can get the information at the same time. So most of the time, the servers are interconnected to the this kind of networks, right? Everybody can access to that server and get the same data in the same time, right? So think about the our Koha service, Koha system. The Koha system is available in a what computer server. That is why everybody can access at the same time. So those are some very famous advantages of networking, data sharing, and information sharing. Then you need less data storage to store the data, right? Most of the time in a network, we use a server computer, right? Server computer. Server computer is a special kind of computer than the normal desktop computer. It has very special features, right? Its capacity, storage capacity is very high. Its speed is very high. Its security level is very high, right? As it has a huge storage capacity. So you need very small, only the server computer is needed to save millions of your information, right? So it may be when you are saving some data in several computers, it is enough one server computer, because server computers has very huge capacity of storage. Common use of resources. So as I already told you, normally, in any environment, even at the home environment or even at the office environment, resources like printers, scanners, web cameras, all those things we are not having for each person. Those kind of things every time we are sharing, because the sharing facility is there. As the sharing facility is there, it's a waste of money if you are going to have printers for each person. If you are going to have printers for each person, it's a waste of money. If you are going to have scanners for each person, it's a waste of money. Therefore, there may be computers, it should be to each person. Otherwise, two people cannot work together in one computer. But taking printouts, if it is a shared printer, everybody can get the printouts. If it is a shared uh, scanner, everybody can scan the document. The resource sharing. By connecting devices such as printers, scanners, etc. to a computer network, the clients connected to that network will have the convenience of connecting to those hardware through their computers. Right? Even the maybe the you can have the shared what else? Speakers as well. Or either you can have the inbuilt speakers in your computer, something. Ability to centrally control software, right? The softwares can be centrally controlled. Installing common software separately on each computer wastes unnecessary time and money. Now suppose we are not installing our Koha system on each client's computer, right? We are not installing some programs like systems, right? So on clients each computer, we are installing the Koha system on a server, one single server. The others will join with this program through the network to the server. Everybody connects to the maybe through the browser or any other special program. They are connecting to the server and will get the use of the program. But in their own computer, their own laptop, their own tab or phone, that system is not installed. They are connecting with the system which is available in the server. The system is available in this server, right? It is available in this server. All these people connecting with the program which suppose is the Koha, right? Koha is installed here. So all these people connecting this Koha system through this network. So we have not installed the Koha in all these client computers. One central software is installed in one central place, and others are joining with that. Next one is ability to connect anywhere, anytime. As the networks suppose the facility to connect from anywhere at any time. So internet is also another kind of network, right? As the internet is there, anybody can connect with the required systems at any time, right? So people can connect with our OPAC in any time, right? You can join with the any kind of website at any time. How? You are connecting with the, you are going through the home network, then the internet and the particular website, particular system. How this feature has evolved? Because the development of networks, computer networks. Then, as there are advantages, definitely there are some disadvantages as well. If there are advantages, always there are disadvantages. What are the disadvantages? Network breakdown. Always we can have, right? In some network designs, the failure of one computer or cable can affect the performance of other computers on the network. Now, these networks, right? Sometimes it is wired networks, not wireless networks. right? Wired network. Then if these wired been damaged either by rats or some other way, right? So if the wire is broken, so you are having problem in your network. The network is not working. Or we are going to learn this. So in the network there are connecting devices like switch, routers, hub, various kind of things. If anything happens to this kind of connecting devices, as these days there are heavy rain with thundering, right? Lightning. So most of the time these things can affect to the these kind of connecting devices, especially lightning. Right? If something happened to these kind of connecting devices, suppose switch is damaged, the router is damaged, then the entire network is not working. Right? So network can have problems with these kind of reasons. Then computer viruses. This is serious issue. As the as always, when there are some advantages, there are some disadvantages. As we are talking about the advantages, we can share the resources and everything. We can share the information. Likewise, because of that, all the things are interconnected. Likewise, as the all these things are interconnected, as you can share the information, you can share the viruses as well. Right? If one computer is affected with a virus, anyhow, there is a high possibility of sharing that viruses to the other computers in the network. If you do not have a proper protection mechanism in your computer, right? Remember that as you can share the information within the network quickly, that is an advantage. Same way, the viruses also been shared among the network quickly as you have networked. All the computers are interconnected. Therefore, if one is affected, definitely there is a high risk to affect all the other network computers in the network. Right? So what you should have is you should have a very good virus protecting softwares in your computer. Right? Like antivirus programs. Each of these computers should have. Otherwise, as you are connected with the network and also you are connecting with the internet, there is high risk to affect your computers as well. When affect, so various problems you can have. Sometimes your softwares are damaged, sometimes hardwares. Right? If your hardware is damaged, so it's a serious issue. Right. Computer errors. Right? Suppose all these computers, all these machines are connected with the server. If the server crashed, what happened? If the server crashed, all these computers will not work. Suppose there's a we are going to learn it's a server computer called gateway which provide the internet facility. right? We need to configure a server called gateway to get the internet facility. If that gateway is broken down due to some reason, right, no one will be able to get internet, right? No one will be able to get internet. So those kind of problems can have. Training requirements. So managing a network requires a specially trained person, network administrator, definitely, right? So to identify the problems and to manage the network, you need trained person, knowledgeable person. Normal general worker cannot identify these problems and solve the issues, right? Network administrators, they should have. Any department, any organization should have a person who is knowing these computer networks to identify the problems, troubleshooting, right? Otherwise, you need to wait days until that problem is solved. Unauthorized access. These days, it is very highly discussed matter these days, right? So one of the major disadvantage of networking is the difficulty of securing data. Unauthorized access to data can occur as any computer on the network can connect to the database or server computer. Now, suppose some person is having very weak password or something. So if the hackers will able to log into that computer, he will be able to log into the other computers as well. That's unauthorized access, right? These days, highly discussed topic in the country. So many things can happen. Luckily, we don't have any power plant, nuclear power plant, and all these things. That's when we compare other things what we have, what happening today. So if we have a power plant like nuclear power plant or something like in this country, so very easily hackers will log into those system and will destroy the whole world. They will take the control because our people don't know everything. We came to know when it happened few days back, right? Unauthorized access. This is a critical issue when you are having networks, right? Those are advantages and some disadvantages, right? Then we are going to talk about the data communication in computer networks, how this data is communicated within the computer, right? So let's first identify what do you mean by data communication? Data transmission or exchange of data. The transmission of data and information can be called data communication. For example, data transmission may occur between two or more computers or between a computer and a device such as a printer. The data transmission can be computer to computer or computer to any other device like printer or scanner or something. For this data transmission, a connection must be established between the source and the receiver. The relationship, the relationship is called networking. There should be a connection between the source and the receiver, right? If you are sending a message to the print a document, source is the computer, receiver is the printer, right? That relationship is called as the networking. That relationship. The components needed for the communication. The following are the basic components that are needed for the data communication. Sender or a source, right? This is sender or source. The person or the object which send the data, right? The medium. Medium is the medium used to transmit the data, maybe telephone wires or wireless medium or the wired medium. Receiver or destination, the person or the object which receive the data. So three components are there: sender, medium, and the receiver. So there are some we need to learn data transmission modes, right? Data transmission modes. One is simplex mode. One is simplex mode. Data is transmitted from the sender to the receiver only. So this is one-way transmission. Simplex mode is one-way transmission. Data is transmitting to the source to the receiver or sender to the receiver only. Receiver cannot send any message to the sender. One-way transmission. One-way road. Right? So like when you are watching TVs, right? Either through any medium, maybe satellite transmission or whatever way, right? So those messages, those waves are sending to the TV station to your TV. But your TV cannot send any message backwards to the TV station. Is it clear? Like listening to the radio. Messages are sending from the radio station to your radio. But you cannot send any, or your radio cannot send any message to the radio station. Through using the same line, na? Through using the same line. That is one way from television station to your TV. From radio station to your radio. Only one way. Those things we called as the simplex mode. Simplex mode. Then the second type is half duplex mode. Half duplex mode. What is this? In half duplex mode, data is transmitted in only one direction at a time. Previous one, always in one direction. Simplex mode, always one direction. There is no way to send the message in other way. But in the half duplex method, you can send messages in one way at a time. Then the next time, you can send the backwards. Right? On half duplex mode, data is transmitted in only one direction at a time. The next time, it is in the backwards. That is, the receiver can transmit data to the source only when the data transmission from the source to the receiver is complete. So, talking with the walkie-talkies are examples of this. Hope you have seen talking with the walkie-talkie, right? So, when this person is talking, this this person can only listen, right? When this person is talking through the walkie-talkie, right? So this person can only listen. Then this person is started to speak. So this person cannot send the message in this way. He can only listen. One message at a time. right? So this is half duplex mode. Then the next mode is full duplex mode. Data is transmitted to both sides at the same time is called full duplex. Like when you're talking through the telephones, both can chat in the same time, isn't it? Normally we are not doing. But if you need both, when you are having a phone call, both can speak at the same time, right? The information is transmitted to both ways in the same time. Telephone conversations is an example for full duplex mode communication. Hope it is clear to you these three communication mode, transmission modes: full duplex, half duplex, and what is the next one? Simplex mode. Is it clear? Right? Hope it is clear. Then we need to learn about something, the data transmission media, that is earlier the mode, the media, different kind of media, data transmission media is used to transmit the data. Medium is used for transmission is another important feature when creating connectors among the systems. There are two types of transmission media: media, guided or wired media, unguided or wireless media. You may have seen both, right? Wired media, wireless media. Both the things are using in our home and office as well. Sometimes, so what do you call Wi-Fi? That is wireless media. When you come connecting to the internet through the network cable, that is wired media. Without knowing, maybe sometimes we are having the experience for both medium, right? Sometimes you may not aware. First, let's discuss about the wired media, right? Wired media. If the medium used for the data transmission is a physical medium, it is called guided or wired media. If you are using the wired physical media, right? So that is called the wired medium, or guided or wired. So different kind of basically main three type of wired are using for this data communication, right? Twisted pair cable, coaxial cable, fiber optic cable, right? You may you have been used these things, but you may not know the exact name why what is these things. But when I show some images, you will realize, okay, I say so. We are using this already, right? Twisted pair cables, coaxial cable, and fiber optic cables. First, let's take twisted pair cable. What is twisted? Right? Pairs of twisted copper wires are used for data transmission. Right? These are again twisted pair cables are going to two types: unshielded twisted pair cable (UTP) or shielded twisted pair cable (STP). What these things are, right? Unshielded twisted pair cable, right? So can you see wires are twisted? Wires are twisted. The unshielded twisted pair (UTP), the twisted copper wire pairs used for the telephone connection. These are very flexible and low priced. However, it is difficult to transmit data for a long distance through UTP wires. it is suitable for maximum of 100 meters. So there are limitation of these different kind of transmission modes, right? So if it is twisted, though it is twisted, unleashed twisted pair, you cannot send the uh, data through a long distance. So maximum 100 meters, right? This unshielded twisted pair. Then twist, shielded twisted pair. These twisted pair cables, right, shielded by a aluminum foil. Right, so aluminum foil has been shielded, have been covered these wires. Why this is needed? So when you are transmitting data through these wires, there are some what do you mean interference, right? So like electromagnetic interference and all those things. So therefore, if this interfering is there, so your data might lost, right, or data might damaged. To avoid that, this kind of aluminum foil is covered by these wires are covered by this kind of aluminum foil for a protection of data, right? So this is bit expensive. These wires are expensive than the uncovered, unshielded twisted pair. But though it is bit expensive, your data is protected heavily. This kind of wire is mostly used in the cases of laying underground wires. Right? Underground wires, if the wires is going underground, so this kind of wires are being used. So hope you have seen this kind of connectors. Have you? Have you seen? From where? Yes, computer lab, when you are connecting your computers, we are using this kind of connectors so to connect to the network, right? So this is what these are the connectors using for this twisted pair cables, right? Two both unshielded and shielded twisted pair cables are using this kind of connectors, right? So there is a way of connecting these things to this point. So we are not going to discuss that part, right? So just remember this type of connectors we are calling as the RJ45 connectors, right? This same thing you can see in the telephone wires. When your telephone is your receiver connect with your telephone line is this kind of same kind of RJ45 connector. Have you just check, right? Your landline, not the mobile phone, your landline, right? So it should be connected with the your telephone wires. So again, the landline, the phone is connected with this kind of RJ45 socket, right? This is a plastic connector that looks like a telephone line connector. RJ stands for registered jack, which means the connector follows a standard from the telephone industry. The standard determines which wire connects to the each pin in the connector. So this has a standard codes to connect with these pins. So we don't need to that much of details, right? So just remember, twisted pair cables are using RJ45 connectors. Then the next type is coaxial cable, right? Again, you may have seen this coaxial cable. This consists of an electric cable pair. The outer cable, which is like a radiate copper net, products electromagnetic field around the center. So this is like a this has two parts. So this is one is it's like a copper net, and it has a middle cable as well. In between, there is a plastic, what do you call this? Plastic cylinder, something like that. So these two has no connection directly, right? This is a copper net, copper cable net, and this is a very rigid copper cable, right? Coaxial cable. Have you seen the TV? So not like this uh, fiber optic line and all, right? So all the days when you have the antenna for your TVs, the cable you fix the antenna and the TV. Have you ever seen this kind of thing? Anybody? Have you? No one? When you have the antenna for your TV, is normal general antenna some old days, right? These days we are using dialog TV and pure TV. We don't need the antenna. But sometimes back, right? So we had the antenna to get the signal to our TV. To connecting this antenna and the TV is using this kind of coaxial cable, right? If you have, still you have, you just check. You can see, right? These two cables are separated by a plastic shield. This is that plastic shield. These cables are expensive and used for the TV antenna and CCTV, right? Coaxial cable. So these are the coaxial cable connectors. So BNC connectors are using, right? So there are two type of BNCs, right? Male and female. So we are not going to learn in depth of this. Just remember, uh, coaxial cables are using the BNC connectors. Then the most famous type of data transmission media is fiber optic, right? Fiber optic. Fiber optic cable consists of pair of an cable. There is a plastic jacket to separate the two cables. Coil is a glass tube and there is a glass cladding around it. So glass is using this as the no copper wire is using in this fiber optic, right? The data transmission is carried out by a while reflecting light. These are used in modern telephone. These are the most popular medium in these days. Fiber optic, very high. This why this is very popular because the speed of transmission is very high compared to the all the other medium. All right, all the other medium, the data transmission speed is very high because it is going as a light. Data is transmitting as a light. You know the speed of the light, right? These are used in the modern telephone networks. The cable is relatively more than now, but it is very expensive. The fiber optic cables are very, very expensive. This is the fastest data transmission media at present. Right? If you have having fiber optic cables network in your network, so your speed is much higher than the other medium, but it is very expensive, right? Very expensive. Maybe two, three, five times expensive than normal twisted pair cables. So these are different type of fiber optic connectors. So we don't need to much pay attention for this one, right? So just remember these kind of this there are two different type of connectors, right? They are using for these fiber optic cables. Okay, that is how we are transmitting the data, right? So we learn different type of data transmission modes, simplex, half duplex and full duplex, and different type of data transmission media, right? Uh, Twisted pair cables, coaxial, and fiber optic, right? So that is wired media. Then we need to talk about the another popular mechanism in these days, wireless media, right? Wireless media. Wired, those things are twisted pair, coaxial, fiber optic, all are wired media. You need a physical medium to transmit the data, right? In the next one is unguided or wireless media. Again, this is very popular in these days because uh, due to various reasons. Data is transmitted as a signal through the air without using any physical medium is called wireless media. In these methods, right, no wired is being used to transmit the data. It's going through as a signals through the air, radio waves, microwaves, infrared. Think about the radio signals which are getting to your radio. Think about the television signals you are getting to your TV, right? So up to your suppose radio signal, you are not connected to any medium, but just your radio is getting the signal through the air. It's true that you are using an antenna to get the clear picture, clear data from the TV station, but up to your antenna, there is no medium. All these things are getting through the air, your TV signals. Until it reaches to your antenna, it is wireless media, right? Radio waves. Radio waves. Data transmission is performed using radio waves, right? So you can give lot of example. Wi-Fi, very famous in these days. Wi-Fi connection. Bluetooth, again, two devices are connected without any wired medium. Bluetooth connection, right? So these days you are having different kind of Bluetooth, right? So these are the example for radio waves based communication. No wire is connected to devices. Always these days, people are having those Bluetooth ears, earbud, right, in their ears and communicating with having calls or listening to the music, everything, right? This younger generation always, so they are having earbuds in their ear every time. Bluetooth. So we are having Wi-Fi networks to connect to the internet. Maybe in our home, maybe in your workplace. That is again wireless media through the radio waves. Next one is microwaves, right? Microwaves. Microwaves travels in a linear mode. Transmission center is positioned facing each other. The distance between the centers are decided based on the geographical factor of the area. Microwaves are used in the satellite communications. Remember, now this satellite communication is again very popular in these days, right? Microwaves are used in satellite communication to transmit data as transponders. Satellite centers, which are positioned in the sky about 36,000 kilometers away, capture data transmitted as microwaves through the satellite towers positioned in the Earth and then transmit the data back to the required tower. Using this method, data can be transmitted to any distance. This is also used in the internet communication. Now, suppose there is a satellite transmission tower, maybe in somewhere, right? So maybe suppose it is in USA, right? USA. So it transmit to the satellite in the sky. Then that information is transmitted to another uh, satellite station in somewhere in Asia, or maybe in Sri Lanka, somewhere. So from America to Sri Lanka, this is going as the microwaves signals. But this satellite communication basically going through as the microwave signals. So any distance you can send the your information. Suppose sometimes not from this satellite, not direct to a station, it is sending that information into another satellite. Then that satellite transmit the data into a faraway station. At maybe faraway station. Right, microwaves. Then the infrared media. Infrared. Infrared transmission is in TV remote control, wireless keyboards, and mouse. Right, so you have seen you are using your TV, what do you call remote controller to change your channels on the TV, right? This kind of TV controller, remote controller. So in that method, it is using infrared. You may have seen when you click this, it's red color things wave is going. Or wireless keyboards and wireless mouse. Those things use this infrared media to transmit the data. Right? They are using infrared media to transmit the data. Hope it is clear to you. Right? Is it clear? Right. Then we are moving to the network architecture. We need to learn how this network is have been designed. Different type of architecture. Right? Network architecture. Network architecture is defined as the physical and logical design of software, hardware, protocols, and media for data transmission. So it count everything, right? Network architecture is defined as the physical and logical design of software, hardware, protocols, and media for data transmission. Simply, it explains how computers are organized and how tasks are allocated to the computers for data transmission. Right? Simply, it explains how computers are organized and how tasks are allocated to computers for data transmission. Two types of network settings are used. One is peer-to-peer network. The other one is client-server network. Sometimes you may have heard, right? Peer-to-peer network and client-server network. First, let's talk about the peer-to-peer network, right? Peer-to-peer. What is peer-to-peer? A peer-to-peer network is a network in which all computers are connected with equal privileges and data processing responsibilities. Now, in a network of peer-to-peer computers, All computers are same. It has same privileges, same facilities. No, there's no such special computer in the network, right? All the computers are same. And all the computers having the connection to each other. This computer will connect with all these computers. And this one again connect with all these computers. But each computer has connected with all the devices in the network directly. Directly, right? These types of networks are useful for small environment, typically up to 10 computers. Peer-to-peer, you cannot have many computers. But if you have very few, less than 10, you can have this kind of computer, this kind of network. But if you have many, like 50 computers, 50 devices, not always computers, right? 50 devices, 100 devices to connect each other. So this kind of mechanism is not suitable because the main reason is that each and every device in the network will connect to the each and every device in the network directly. If there are computers, 100 computers here, this computer connect directly with these 100. So it's a very problematic when it's making the transmission of data. So it creates a huge traffic. It creates a huge traffic. So here no dedicated server is there. No central server. Each and every devices are connected with each and every other. Each computer given a special permission to share resources. But this can lead to a problem if the computer with the resources goes down. Right? So this is peer-to-peer networks. Normally these kind of networks are not creating these days because this has so many issues. Right? So many issues when you are creating this kind of peer-to-peer network. So let's see some advantages and disadvantages of peer-to-peer networks. Advantages, it is less expensive as it does not have any dedicated server. Because if your system, if your network is having a server, so always server computer is very, very expensive than your desktop computers. Even if one computer stops working, the other computers will not stop working, right? Easy to set up and maintain. So those are some of the advantages. Disadvantages are, as there is no centralized system, it is difficult to get backups as the data is indifferent. So there are so many computers in the network. So you need to take backups from each computer. If there are 10 computers, so you need to take backups from each computer, right? Otherwise, you miss some data. But if you have a one central server, so you need to take backup only from that server only, one server. But here, every and each device is in the network, so you need to get the backups. It has a security problem as computers are managed separately. So always you have some security issues, right? That is the advantages and disadvantages of the peer-to-peer network. The next type is client server network. Next type is client server network. Right. Client server. A client server network is a network model designed for end users known as clients to access resources from a central computer called a server. Now, so the people who are using the at the end of the this one is these people are called the clients, right? Who are people who are using the network, clients. So clients are using through the network or the internet a central computer, right? All the data is available in this central computer. People will connect with this central computer using different devices. It may be a laptop, it may be a desktop, or it may be a mobile phone or any other digital device. The central controller is called a server and all other computers on the network are called clients. Right? These are client computers. This is the server computer. All major operations such as security and network management is performed by the server. Right? Server is responsible for many actions in this network. All clients communicate with each other through the server. If this computer wants to communicate with this one, so it should send a message to the server and need to connect with this one. This computer cannot directly communicate with these devices. Earlier, in the peer-to-peer, particular computer has the mechanism to directly connect with these other devices. But here, you cannot do. If this computer wants to communicate with these two, it should send a message to the server, then the server sends the message to these two devices. That is how it going to connect. The client server mechanism. So again, there are some advantages and disadvantages. Advantages are in this client server network, sorry, a client server network contains the centralized system. There is a centralized server, so data can be backed up easily. So you don't need to back up every and each device separately. So the data is stored in the server computer, so you need to take the backups only from the server computer, not from the client machines. A client server network has a dedicated centralized computer that improves the performance of the entire system. Right? Security of the client server network is better as a single server administrators shared resources. The speed of resource sharing is high. The disadvantages, client server network is expensive as it requires a server with a large memory. So always a server computer is a very expensive because it has very unique features than the normal desktop computers. So always a server computer is costly. The server should have network operating system to provide resources to clients, but the uh, network operating system is again very high cost. So server computers you cannot have normal operating system which we are using like normal Windows 11 or something, right? So you need specialized networking operating system like Linux or Windows NT, Windows. There are so many other network operating systems specialized for the networking. So you need to have this kind of operating system in your server. Otherwise, it is not going to work, right? So the security and other networking facilities are available in those networking operating systems. So those networking operating systems, again, the cost is very high. Cost is very high. A dedicated network administrator is required to manage all resources. That's as we told, discussed. Right. So always when there's a computer network, a dedicated knowledgeable network administrator is required to manage the network. Otherwise, so the problem and the issues coming with the networks is not easily solved. Okay, next one is computer networking, connecting devices. So I'm going to have a small break here. So let's have this part after the break. හරි. අපි ආපහු පාඩම පටන් ගමු. So, computer networks connecting devices, right? Connecting devices. So this is when you talk about the network. So these connecting devices play a major role in any computer networks, right? So these connecting devices has different aspects, different use, right? So without these kind of connecting devices, you cannot build up a network at any time. So every when you build any kind of network, right, even it is wired or wireless, so you need these kind of connecting devices. Different kind of connecting devices are using in different kind of networks depending on the requirement, right? There should be two or more computers build a computer network, right? Connecting device used to connect the computers with each other. Maybe to connect the computer devices, or maybe connecting to a one network to another network. So depending on the requirement, different kind of connecting devices are using. It can be so different type of maybe the network interface card, hub, switch, router, modem. Those things are the most common networking devices are using in the different kind of networks. First, let's take uh, network interface card. That normally what we call as a network card. Without network card, networking is not possible. This is also known as the network adapter card, Ethernet card or LAN card, right? So any computer, if you are willing to have the network connection, you should have a network card. If your computer does not have any network card, you cannot uh, connect with any kind of network, maybe wireless or wired. Network card allows a networking device to communicate with other network devices. Right? So what this network card is doing, so it allows to communicate with the other network devices. So without this network card, you cannot communicate with the other devices in the network. A computer uses parallel data transmission technology to transmit data between its internal components. So within the computer, right? So data is transmission a mode called the parallel data transmission within the computer, right? So from the computer to the network card, data is coming as the parallel data transmission, right? But when you going through the network, one network card to other network card, this medium may be a wired network or wireless network. Wired medium or wireless medium from this network card to this network card from another computer. So data is going as the serial data transmission, right? When the data going out from this computer as going as a serial data transmission, it catches the other network card in this computer. And from this network cards, so this serial data cannot be go through the network. Sorry, cannot be go through the computer. So this network card converts this serial data transmission to the parallel data transmission. Here, when the computer send the data through using the parallel data transmission to network card, so this network card convert this parallel data into serial data as it is needed to send through this different kind of medium to another computer, right? A computer uses parallel data transmission technology to transmit data between its internal components, and serial data transmission technology is used to maintain communication between different components. Network cards converts parallel data to stream to serial data stream and serial data stream to parallel. So when it is going out, right? So this parallel data is converted to the serial data through this network card. When it's coming in, this serial data is converted into the parallel data in this computer. So this is how this network card is working. So you can have a different kind of network cards. So these things are very old network cards. So using this coaxial cable, right? So these days you can see this kind of ports in your computers. Have you? These ports is using these RJ45 connectors, right? This kind of wireless antenna sometimes you can see these days. Those things are, when earlier these kind of wireless antennas are there, but now in the computers those wire antennas are not visible. These things are inbuilt in the computer when you connect to the Wi-Fi, so you don't need this kind of with your laptop, so you don't need this kind of antenna, so it is inbuilt. With the technology developed, these antennas are inbuilt in your motherboard, but it is there, right? It is there. That is how you were able to, that is why you were able to connect with the Wi-Fi connections. Then next device is the hub, right? Next device is the hub, very the primitive device you are using for a this connecting, right? Primitive device hub. What is a hub? What is a hub? What is a hub? Hub is a network device used to connect several network devices as well as for data communication. When a computer sends a data packet, so in a computer terms, in the computer terminology, we are explaining data is transmission as a packet, a parcel, like a packet, data packet, right? Not single characters. So it's a computer term. So when the theories are explained, normally we are explaining data is going as a packet, right? When a computer sends a data packet to the hub copies the data packet to all its connected devices. All devices on the network know about this data packet, and the device to which packet must be traveled claims the packet. Copying data packets to all devices causes unnecessary slowness and congestion. In information exchange, hubs implement the half duplex method. Now, these are the computers 1, 2, 3, 4, 5. These are the networked computers. And this cage explain the hub. What hub does? When this computer send a message, hub send that message to all these computers. But that message should go to one particular computer, right? That is 4. This computer send a message to computer number 4. That is the, this is the sender and this is the receiver. this one computer wants to send a message to number 4 computer. But when you send the message to the hub, it doesn't directly send the message to only to the number 4. It sends to all these computers 2, 3, 4, and 5. Right? All the computers will get the message. That is the nature of the hub. It doesn't filter the required person. It doesn't filter the required person, right? It doesn't recognize the required person. The hub doesn't send the message what it received only to the person who need it. It sends the everybody who connect to the hub. When you send the message to everybody, then when the message goes to the 2, it identifies this is not for me. When the message goes to the number 3, it identifies this is not for me. When it goes to number 4, okay, so it identifies this is for me. And again, number 5 will identify this is not for me. Right? So when the hub sending these messages to everybody which is connected to the hub, it creates unnecessary traffic because this message should not go to the 2, 3, and 5. It should go to only 4. When sending this one, it creates unnecessary traffic in the network. Therefore, because of this unnecessary traffic, so sending this message will take sometimes slowness in the network. It takes time to send the message to correct person because first it should go here and it should go here and it should go here and again it should go here. That is how a hub is working. Hope it is clear to you. So different type of hubs are there. Two type of hubs are there: passive hubs and active hub. Passive hubs and active hubs, right? Passive hub forwards the data in the same format as it was received. Here the data is not changed in any way. Passive hubs, so when how the data is receiving, it send the data as it is without changing anything, right? That is passive hubs. Active hubs, it works the same way as passive hubs work, but the data grows before it moves forward. Because of this added feature, the hub is also called a repeater. Now, when the data coming for a long distance, this signals is weakened. The signal strength will be reduced, right? Then when it is going further and further, so sometimes when the receiver will not get the original message which is sent by the source, right? That is how the passive hub is doing. But when you have the active hub, it does not change the content of the message, but active hub increase the strength of the signal. Then it has more strength to go further, more distance, right? So when you consider a race, marathon, sometimes at some points people will having some drinking water and other things to increase the strength of the runner or cyclist, right? Likewise, this active hub make the signal more strength. Signal strength is increased by the active hub. This kind of active hub sometimes called as a repeater. Repeater. Repeat is a kind of a hub. Right? Kind of a hub. Then next type of component is switch. Next type of component is switch. Right now we have hub, repeater, then the next is switch. What is the switch? Like a hub, a switch also operates on a local area network. But a switch works more intelligently than a hub, right? So switch has more advanced features than a hub. A switch is used to avoid collisions and other effects on the network. A switch is used to avoid collisions, right? Switches control the network traffic based on the address information in each data packet. The switch reads the destination address and forwards the data packet directly to the recipient without sending it to all devices on the network. This process is sending data reduces unnecessary traffic and cog- congestion in the network. In the information exchange, the switch operates the full duplex method. So, what is this switch is doing? In the hub, when the hub is receive the message, it sends all the components of the network. But switch is more intelligent than the hub. So when the switch get the message, he identified the correct destination of the of the receiver. When one sender is sending a message to the switch, he identifies the correct address of the receiver. Then he send the message only to the receiver. The switch does not send to all the devices in the network. So this is more advanced feature compared to the hub, isn't it? Right? This reduces the traffic heavily because he send the message only to the receiver, does not send to all the people. Suppose, so this one three send a message, right? Only to three. One send message, so he wants to send this message to this one. Connection and send the message. So this one send the message. This does not get any message at this time. So when a send the message, switch identify the correct address and send the message to only to the correct person, not to all the people in the network. So this is a switch, how the switch is operating. So these are kind of switches. Hope you have seen, right? If you have go to your computer room or a place where your network has established, definitely you should this kind of devices connecting with many wires coming from different ports of the network in your building, in your room. Have you seen this kind of device from anywhere? Right. Next one is router. Now we learn lot of things, right? Hub, repeater, switch. Now next one is the router, right? Next one is the router. What is a router? A router is a network device that transmits information between two or more computer networks, right? Two or more computer networks. Now, up to now, we discuss about the devices which transmit the data among the devices, right? Within one single network. Now, a router is a different one. because router distribute the data between, not among one particular network, among the two devices. So two networks, two different networks, right? Two or more computer networks. A router is designed to receive, analyze, and forward data packets between computer networks. This is one network, and this is another network. And this is the router. Router is connecting to the internet. A router examines the IP addresses of a given data packet and uses the headers and forwarding tables to determine the best route to forward the packet. A router is used in LAN and WAN environments. For example, it is used for Office to connect different network devices and can also be used to establish connectivity between the remote networks. A router is more expensive than other devices, such as switches and hubs. Okay, so in this network, consider some devices are there. That network is connected with the switch or hub, most of the time switch. And this network again connected with this switch, right? This switch. And these are two different. Suppose this is sales department and this is account department. So it may be in two floors of the building, right? Two floors of the building or two rooms in the building. So this is one network and this is network. These two networks connect together through this router. This is more intelligent devices. It has IP addresses of this network and that network. So it knows directly when the message comes to here, where to send it. And also this router is connecting with the internet. It's something, and if this network want to send something, suppose an email for for not this network, outside internet, so it goes to this router, right? So router is a device which used to connect two different networks, not two different devices, right? So I found a very good video from YouTube which explained the difference between the hub, switch, and router. So let's watch this one. So you will realize the things what I have already explained. Okay, let to share the sound. Can someone tell me whether you can hear the voice of the video?
Hello everyone. In this video, we're going to
Yes,
talk
sir,
about
we
the
can
difference
hear.
between a hub. Hello everyone. In this video, we're going to talk about the difference between a hub, a switch, and a router. Now, all three of these devices are similar, but there is a difference in the way they handle data. So we'll first talk about a hub. Now, the purpose of a hub is to connect all of your network devices together on an internal network. It's a device that has multiple ports that accepts Ethernet connections from network devices. Now, a hub is considered not to be intelligent because it does not filter any data or has any intelligence as to where the data is supposed to be sent. And that's because the only thing a hub knows is when a device is connected to one of its ports. So when a data packet arrives at one of the ports, it is copied to all of the other ports. So all the devices on that hub sees that data packet. So again, a data packet comes into one port, then the hub will just rebroadcast that data to every port that has a device connected to it. So even if this computer here only wanted to communicate with this computer over here, these other computers would still receive the data even though the data was not intended for them. So when this happens, it not only creates security concerns, but it also creates unnecessary traffic on the network, which wastes bandwidth. Now, a switch is very similar to a hub. It's also a device that has multiple ports that accepts Ethernet connections from network devices. But unlike a hub, a switch is intelligent. A switch can actually learn the physical addresses of the devices that are connected to it, and it stores these physical addresses, called MAC addresses, in its table. So when a data packet is sent to a switch, it's only directed to the intended destination port, unlike a hub where a hub would just rebroadcast the data to every port. So as an example, if this computer here wanted to communicate with this computer over here, the data packet arrives at the switch, and then the switch will look at its table of MAC addresses and matching ports and deliver the data to the correct port. And then the data packet would only go to that computer. So that's the major difference between a hub and a switch. So as a result, switches are far more preferred over hubs because they reduce any unnecessary traffic on the network.
Okay, so how this switch work? So not like a hub, but switch has the addresses of these each devices. We call it as the MAC address, right? So it saves these MAC addresses in the switch, or the MAC addresses of all the connected devices. It was saved in the switch. When this computer send a message to this one, so it identify what is the MAC address needed to send this message. So it directly sent to this computer, not like hub, right? So therefore, the switch is more intelligent than the hub.
So as a review, a hub only detects that a device is physically connected to it, and a switch can detect specific devices that are connected to it because it keeps a record of the MAC addresses of those devices. Now, hubs and switches are used to exchange data within a local area network, for example, such as in your home network or in a business. They are not used to exchange data outside their own network, such as out on the internet, because to exchange or route data outside their own network to another network, such as out on the internet, a device needs to be able to read IP addresses, and hubs and switches do not read IP addresses. So that's where the router comes in. Now, a router does exactly what its name implies. A router is a device that routes or forwards data from one network to another based on their IP address. When a data packet is received from the router inspects the data's IP address and determines if the packet was meant for its own network or if it's meant for another network. If the router determines that the data packet is meant for its own network, it receives it. But if it's not meant for its own network, it sends it off to another network. So a router is essentially the gateway of a network. So here we have a private network with its router, and we'll refer to this as the red network, indicated by the red colored screens on the computers. And over here you're going to have different data packets, indicated by their different colors, which represents different IP addresses, and they are going to be entering the red network's router from the internet. Now the router is only going to accept the red data packets because they are the only ones that are intended for this network. So all of the other data packets, the yellows, blues, greens, etc., will be rejected by this router because they were not intended for this network because their IP addresses were not meant for this network. Now here is an expanded view of routers over the internet. There are 4 networks here, indicated by their different colors, and each network has their own router, along with their hubs or switches and their computers. So right now, as you can see, each network is just exchanging information within their own network. Their data is not going out on the internet, so they are not communicating with other networks. They are just exchanging data within their own network using their hub or switch. Now let's go ahead and exchange data between different networks. So let's say, for example, that this computer here on the red network wants to communicate with a computer here on the blue network. So for this to happen, the data packet has to leave their own network and go out on the internet. So the computer sends their data, and it goes to the network's router. And once the data packet reaches the router will look at the IP address of the data packet and then forward the data out on the internet to the next router, and then make its way to the blue network's router, and then to the intended destination computer. So in a nutshell, this is how routers work. So in conclusion, hubs and switches are used to create networks, while routers are used to connect networks.
Okay, it is. Hope it is much clear now how this uh, hub, switch, and router is working. This is very good video. Very simply to explain how this goes. Right. So, as I earlier explained, so routers are the things, devices used to connect different networks. Right. So it has the IP addresses of these networks. Right. So of these computers. So it directly forwarded the message which is required network, not to sending everybody. So hope it is much clear now how these devices like a hub, repeater, switch, and router is working, right? Then next connecting device is the modem, right? Next connecting device is the modem. So hope already you have heard this word modem. A modem is a device used to connect computers on a computer network or a personal computer used at the home to the internet through a telephone line. So when you need to connect the internet, you need a modem, right? When you need to connect to the internet, you need a modem. A modem acts as a data converter, right? That is, the digital data and the information in the computers are converted into analog signals that is can be transmitted to the telephone line, and the data and information that are available as signals, analog signals on the telephone line are converted back to the digital signal. So something you need to identify. In a computer technology, we talk about in the computer, data transmitted in as the digital signal, right? So digital signal cannot be transmitted through the telephone or other kind of wires because it is very simply destroyed. It cannot take for a long distance, right? Digital signals are not transmitted through the wires, but within the computers or any other digital device like your mobile phone or tab or whatever, the signals are transmitted within the digital device as the digital signals. When that when those digital signals are going out from the digital device, it should be converted to the analog signal, right? Analog signal. Otherwise, those data will not be able to transmit. So again, when the computers are getting the signals as the analog signals, so those analog signals should be converted into the digital signal to understand to the computer. This converting to analog to digital, sorry, digital to analog and analog to digital need the one particular device is needed. That is the modem. Modem is converting this digital to analog, analog to digital. So this process called as the digital to analog process called as the modulation. In English, in terminology, technical terminology, converting digital signal to analog signal called the modulation. And converting the analog signal to digital signal called the demodulation. Modulation and demodulation. Combining these two words, people have created the new word modem. Modulation and demodulation. Modem. Modem word coming with that way. Combining the word modulation and demodulation. Modem is a combination of these two words. There are several type of modems, right? Internal modem, external modem, and wireless modem. Internal modem, external modem, and the wireless modem. Then we need to identify the task of modem and router, right? Modem and router. A modem is needed to connect to the internet, right? A modem is needed to connect to the always. If we are going to connect with the internet, we need a modem through an internet service provider, and the router is needed to connect different devices on a network, including a modem, right? Therefore, a router allows multiple devices to transfer data from one location to another. A modem is the carrier that sends data, and so even in the even in the home network, we need a router and a modem. If we are connecting, suppose either different kind of service providers are there, maybe SLT, Mobitel, Dialog, or whatever. Always you may have seen there's a router. We call it router, but basically that router is inbuilt with the modem. Though it is called as a router, right? Though we called it as a router, there is an inbuilt modem in that router as well. That router is doing two things. One is, as there is an inbuilt modem there, it connect with the internet. So as it connect as the working as the router, it connect the other devices as well, right? So I have another video explain the difference between the router and the modem. Let's watch this as well.
Hello everyone. In this video, we're going to talk about the difference between a modem and a router, because a lot of people actually think that a modem and a router are the same thing, but they are not. They are different with two separate roles on a network. So I'm going to explain the difference between the two. Now, if you want internet inside your home or business, you have to have a modem. A modem is what brings the internet into your home or business. A modem establishes and maintains a dedicated connection to your internet service provider to give you access to the internet. Now, the reason why you have to have a modem is because of the two different types of signals that are used on a computer and on the internet. A computer only reads digital signals, while signals out on the internet are analog. As analog data comes in from the internet, the modem demodulates the incoming analog signals into a digital signal so that a computer can understand it. And a modem also modulates outgoing digital signals from a computer into an analog signal as it goes out on the internet. And this is where we get the word modem. The word modem means modulator-demodulator, which is exactly what a modem does. It modulates outgoing data from a computer and demodulates incoming data from the internet. Now, a router comes in after the modem. Now, there are different types of routers. There are routers that are used in businesses and larger organizations, and there are smaller routers that are used in homes and small businesses, but they basically do the same thing. But for this video, we're going to use the small office, home office router that most of us are familiar with. Now, a router is what routes or passes your internet connection to all of your devices in your home or business. It directs it to all of your computers, tablets, phones, and so on, so that those devices can access the internet. A typical small office, home office router like this one here will have a built-in switch with multiple ports so that you can connect multiple devices using an Ethernet cable connection. And it also functions as a wireless access point so that wireless devices such as tablets and laptops can have internet access. Now, technically, you really don't need a router if you only want one of your devices to access the internet. You can just plug that device's network cable directly into the modem, and then you'll be able to access the internet. However, like most homes and businesses, you're going to have multiple devices that need access to the internet, and that's where you would need a router. There are also different types of modems. Two of the most common types are cable and DSL modems. So depending upon what type of internet you're going to use, you need to use the correct type of modem. Cable modems are connected to your home using a coaxial cable. Cable is typically provided by the same company that provides you with cable television, such as Comcast, which is one of the largest providers in the United States. And DSL modems are connected using a typical phone line. DSL is provided by companies such as AT&T, which is the largest provider in the US. Now, a lot of times, your internet service provider, when they send you a modem, or if you were to buy one at the store, the modem might be a modem-router combination. So it will be a modem with a built-in wireless router in one physical device, such as this one here. So here is an example of several different networks on how they connect to the internet. For example, this network here on the left is using a cable modem, and it's using a small office home office router so that its computers and the tablet can have internet access. On the bottom we have another network, and this network is using a DSL modem, and it's also using a small office home office router so that its computers, the laptop, and the tablet can access the internet. The network here on the right is an example of a business network, and it's using a cable modem, and it's using a business router so it can connect its computers and its server. And finally, we have the network here on top, and this only has one device that needs internet access. So it doesn't need to use a router. It can just directly connect to the modem because only one device needs internet access. Now, if you're wondering how hubs and switches relate to routers and modems, especially if you saw my other video where I explained the differences between hubs, switches, and routers, well, keep in mind that most routers will have a built-in switch inside of them. So there's no need to have a switch if you already have a router that has a switch built into it. So for example, a router like this may have a 4-port integrated switch so that you can connect 4 Ethernet cables for your wired devices. So the only time that you may need to add a switch to this network is if you needed more wired connections for your devices. So you can just connect a switch to your router and then add more connections to the switch. So just to clear things up even more, over here we have the internet with all of its routers. Then as the internet is routed into this private network, it first reaches the modem. Then it goes from the modem to its router with its integrated switch, and then it's passed to all of its computers.
Okay, so hope it is much clear now, right? So I'm going to stop at this point, right? Even so, how we are going to even at in our home network, so you don't see any router and the modem separately as it the video explained. Nowadays this it's coming as one device connecting all these routers and the modem together. So that device acts as a router, as at also it acts the modem. So that is how we are having the separately these devices. Right, so I'm going to stop here, and now again I am going to give this week's question, right? Right. This is the question for this week, right? So assignment number 2, explain briefly the importance of having the primary key in a table. Right? Explain the difference between primary. The second question is explain the difference between primary key and composite primary key with examples. So hope you remember the conditions. You need to mention your name, university registration number, and the course on the paper top. So I will send the email address. Right, I will put it to the chat. So I hope you are having already. So there are 4 people. So I expect to send all those people this answer. Now it is almost 11:25. right? So before 12 o'clock today, 12 noon. So hope everybody can send the answer, right? So today only you, four of you are going to get the marks. Others will not get any marks because they not did not join to the session, right? So this is a question. Two questions are there. One will get 5 marks for each. Explain briefly the importance of having primary key in a table. Second question is, explain the difference between the primary key and composite primary key with examples. Right? So as I told you last time as well, don't go to the ChatGPT and also don't put those answers to me. Right? So I would like to have your genuine answer. Right. Hope you can start. So please email me